For those of you that do not know me, I'm Miss Gallen. I don't know how I feel about being in the picture, but I think I'm going to try this since not everyone knows me. I will not be the one always doing these video lessons, but you've got me for this week. It'll rotate, so sometimes you'll have your teacher if I'm not your teacher. So let's get started with our our first new lesson of this school year. How exciting! So our first objective, we're just going to get right started here. So hopefully you've got somewhere that you're taking notes. Maybe you've printed out the presentation, or maybe you're just writing it on separate paper. But I would encourage you to keep your notes however you're doing them. This is really the first new lesson. So the objective here is I will perform and examine translations. So maybe that word sounds a bit familiar to you, of points, of shapes, and of lines, right? So you probably have some background knowledge of lines. We reviewed them a bit last week as well with different linear equations. This will happen more in class when we review this, right? So come with those questions, and we're going to be doing these on and off a coordinate grid. So this is where we're going to be starting. Our focus is going to be more on points and shapes. You'll learn some new vocab throughout this, and I'll be sure to write it down and give suggestions as we go. Before we can really dive into what a translation is, I think it's really important that we talk about what a rigid transformation is, right? So this is it's like a translation is under this umbrella. So think of this as like the center of my web. I don't even know if that's how exactly I want to say it. And one of the things off of this is a translation, or it's like a family tree, right? So a rigid transformation. So a transformation is like when you're moving something. Maybe you remember from Algebra 1, it was like shifting or sliding and flipping and turning. Like those are transformations, right? And you did those probably with maybe parabolas and lines was a big focus. Rigid, if something is rigid, it's going to keep its shape and size. So a rigid transformation is a transformation that maintains. So rigid, it maintains its shape and size. So it's not just a transformation. It is a rigid transformation. And so a translation is one of the rigid transformations. There's actually two others. Maybe you know what they are. Reflection and rotation. And obviously I can't ask you for you to answer right now, but there's a non-rigid transformation. So a non-rigid transformation is a transformation that does not maintain its shape or size. And one of the non-rigid transformations, and this will come up later on in this course, it's not even in this unit actually, is going to be a dilation. Okay, so our focus during this lesson today is going to be on these translations. So translations are, maybe you know them as a slide. We are going to be precise with our vocab, and we're going to use that word translation. So if you try to use that word slide, no, that's not going to work for this. So if you translate it, you can translate something slide/move is maybe what you're thinking of. Shift might be a word that came up. So it can go left, it can go right, it can go up, or it can go down. If we're talking about something on a coordinate grid, what moves left and right? X. What moves up and down? Y. Right? So these are going to be things that are added or subtracted from our X and our Y value. That's what's going to make it move those ways. Rotation. I guess maybe you knew this as turn. Right? So some of the things that are important with a rotation is think about the degree, right? If you're rotating 180 degrees or 360 degrees, the center of rotation, right? What is it rotating around? So if you think about a clock, I'm pointing to my clock. If you think about a clock, like the hands are rotating, eventually 360 degrees, but the center of rotation is going to be the center of the clock, right? Like they're rotating around that center. And the direction, right? Is it clockwise or counter clockwise. And you'll get more into this. This will come up. This will have its own lesson. Don't worry. So clockwise is going to actually be a negative rotation, and counterclockwise would be a positive one, right? Just some interesting things to think ahead on. And then our last one down here, which I kind of wish I had switched these orders, because when you learn it, you'll learn translations and then reflections, and then finally rotations, because these are the most strange to us, most involved. So a reflection, like think about like a mirror image, maybe. I'm trying to think what maybe you guys have used the word flip in algebra, and we're going to use just these 3 words, so we're going to be pretty precise. And you can reflect over a line or a point, right? Our focus will be a lot more on lines, and the lines that we'll stick with are the axes, right? So the x or y axis, and some main lines like the line y equals x and the line y equals negative x. We'll talk about how you can do other ones more so in class, but these are the main 4 that we'll talk about as a group. So with that being said, let's turn our attention to translations. I want to, and I'm not going to do this every single time, don't worry, but I want to show you guys this website called School Yourself, because I think it is an amazing website, and I usually have my students and you guys go through this website as you're learning. And so I'm not going to do it every single time, but I'm going to actually play it during this video right now and go through it. And then my hope is that maybe if you're struggling, or if you're looking to get ahead, you're looking for some enrichment, whether you're on either end of it, that you're going and checking out this website, because it's awesome for things, whether it's in geometry or other content areas. So I'm going to go ahead and I'm going to go to my internet, and I'm going to type in schoolyourself.org. And it's going to take me to this website. I never actually have to create an account. I can if you want to. You actually don't need to. And I'm going to click Learn Now. And it's slowly going to load. And there's so much on here, right? You can see all these different content areas. We're going to go with geometry because that's what you guys are taking. And I'm going to scroll down. You can see all these different geometry topics. And, oh, check that out. We're doing transformations. So I'm going to click transformations. And this first one, I'm going to do translations. So we're going to do this together so I can kind of model what it's like. But I love this website.
To get started, go ahead and select the point -2, 1.
Yeah, -2, 1.
Great. So here's -2, 1. Now, when you translate something, that's a fancy way of saying that you're moving it. So if we were to translate this point, -2, 1, 2 units to the right and 3 units up, then we would wind up at this point over here, which is 0, 4. So now let's start with the point 4, 2 over here. If you translate this point 3 units left and 5 units down, then where do you wind up? Select the resulting point.
3 units left and 5 units down. 1, 2, 3, 4, 5.
Nicely done. So if you start at 4, 2 and you translate this point 3 units left and 5 units down, then the resulting point is 1, -3. Now suppose we have a few points on a graph. How can we write down the way that we're translating them? Well, suppose we're moving them 3 units to the right. In other words, we're adding 3 to their x coordinates. So after this translation, the generic point x, y would have an x coordinate of x plus 3.
You're adding 3
whatever
to just
x
your x
equals,
value. That's
after
right.
this translation, the x coordinate will be x plus 3. And if we move the points 2 units up, that's the same as adding 2 to their y coordinates. So here's how you can write down a translation that's 3 units right and 2 units up. X, y is being translated to x plus 3, y plus 2.
The whole
So next,
thing needs to be
suppose you
written
have
down.
the translation x, y to x plus 4, y minus 1. If you apply this translation to the point 3, 5, what are the resulting coordinates?
Just going to plug in, right? 3 plus 4, this is going to give me a 7. 5 minus 1, this is going to be a 4, right? So right 4, down 1. Right 4, down 1.
Right, so the resulting x-coordinate is 3 plus 4, or 7, and the resulting y-coordinate is 5 minus 1, or 4. Next, suppose you have the translation x comma y to x minus 2 comma y plus 3. This time, I'm not telling you where you start, but after the translation, you're at the point negative 3 comma 8. So then what were the coordinates of the original point before the translation?
Okay, so this is going backwards. It's like I have this equation. Can I write on this? And it's almost like I can say x minus 2 equals negative 3. Like that was my answer. I'm not going to plug in. Oh, it's those 2-step equations, or this is a 1-step equation that we reviewed last week. Right, so I'm going to get a negative 1 there. So my original x value must have been a negative 1. Let's see if that makes sense. Negative 1 minus 2 is negative 3. Well, what would this have to be? What plus 3 is 8? 5. If you want to set the equation, y plus 3 equals 8, subtract 3. So you're working backwards. You're doing the opposite.
Excellent. The original point was negative 1 comma 5. If you translate this point by subtracting 2 from the x-coordinate and adding 3 to the y-coordinate, you indeed wind up at negative 3 comma 8. Next, suppose you perform the translation x comma y to x plus 1 comma y minus 1, and then you perform a second translation, x comma y to x minus 5 comma
That's like
y
4
minus 6.
things, actually.
What does this mean? Well, let's pick a starting point, like 2 comma 4. Now the first translation is adding 1 to the x-coordinate and subtracting 1 from the y-coordinate, so that's over here. Then the second translation is subtracting 5 from the x-coordinate and subtracting 6 from the y-coordinate. So now we're over here. So you can think of these two translations as being a single translation. Going from the start to the finish, you had to move 4 units left and then 7 units down. So this translation is x comma y to x minus 4 comma y minus 7. And you might have noticed that to combine these translations, you first added 1 to the x-coordinate and then subtracted 5. Adding 1 and subtracting 5 is the same as subtracting 4. And for the y-coordinates, subtracting 1 and then 6 is the same as subtracting 7. So now suppose you perform the translation x comma y to x minus 3 comma y plus 2. And then you perform a second translation, x comma y to x plus 8 comma y minus 4. Applying these two translations is the same as applying which single translation?
Okay, so it went left 3 and then right 8. Left 3 on a number line and then right 8 is like going right 5. Right, so let's see, does this make sense? If I go up 2 and then down 4, I went down 2. So there you go.
Exactly. Subtracting 3 from the x-coordinate and then adding 8 is the same as adding 5. And adding 2 to the y-coordinate and then subtracting 4 is the same as subtracting 2. So if you perform these two translations, one after the other, that's the same as translating x comma y to x plus 5 comma y minus 2. Now one more thing. When we say we're translating a shape, that means we're translating every point in the shape. So consider the translation x comma y to x plus 3 comma y plus 2. Suppose we want to apply this translation to this triangle and this ellipse.
The same amount. That's the idea of rigid.
These shapes 3 units right and 2 units up. To do this, it helps to keep track of a few points in the shapes, like the triangle's vertices or the center of the ellipse. So let's move the shapes 3 units right and 2 units up. You can see that by translating the shapes, we applied the same translation to each of these points. So if you apply the translation x comma y to x minus 4 comma y minus 3 to the rectangle in the middle of this graph, which rectangle do you get?
So it goes left 4, down 3. Every single point went left 4, down 3. Left 4, down 3. Left 4, down 3. So there's not like a different notation for each one. They all have the same one. Like this is running every
vertex. You get the rectangle in the bottom left.
Amazing.
And you can check that by applying this translation to any point of the original rectangle, like the vertex in the upper right. If you subtract 4 from the x-coordinate and you subtract 3 from the y-coordinate, then sure enough, you have the upper right vertex of the translated rectangle.
Okay. Isn't that awesome? So if you printed this out, there's a capture sheet that goes along with this. And so translation is just a fancy way of you are saying you are, I think it said moving something. How can you write down a translation that is 3 units? Oh, that's the wrong right. How embarrassing. Right, and 2 units up. So x comma y, we need that. I already wrote it. 3 units right, x plus 3, y plus 2. Right? It's almost like an equation or a formula. If you perform this and this, and the same is the same as performing one single transformation. Remember, this was left 3 and right 8. X plus 5, up 2, down 4 is like down 2. Translating an entire shape means you're translating every single point, which for something like a rectangle, do the vertices, right? Pick out key vertices or key points that would allow you to make sure that it's maintaining its shape. Right? If it's rigid, it's maintaining its shape and size. It shouldn't be changing. Every single point, the same direction and amount. That's probably not the exact wording. So let's do some practice with that. So I'm going to do these. I have a variety of practice. I'm going to start with these 3. If you apply the transformation, x minus 3, so this is what we call, this is called a coordinate notation. Coordinate notation. And sometimes it's called a function rule. Sometimes it's just called a rule, right? That's what this is referring to. This, and notice I did the entire thing. I'm not throwing out that x, y. It's important. I want to know where it started and where it's going. So you're applying it to this point, -5, 4. What are the resulting coordinates? So the resulting coordinates, let's plug it in. -5 minus 4 is going to be -9. 4 plus 3 is going to be 7, right? So this is x, this is y. I'm substituting it in. So my resulting coordinate would be -9, 7. This verbally means left 4, up 3. The point A has been translated 2 units down and 6 units left. The resulting points, you know the final point? What are the coordinates of the pre-image? That's a new word. So the pre-image is the one that you're starting with. The image is the one you're ending with. So this is referred to as the image. So you want to be careful there. Pre-image is the starting one. So I want to work backwards. There was one that we just did like this on the school year side, right? So if you went 2 down, so let's write actually the coordinate notation. We started with x, y, and it became x, 6 left, x minus 6, y minus 2. So when we did x minus 6, we got 6. So that means that x must be 12. Right? And when we did, sorry, I'm going to go over here a little bit, y minus 2, we got, because we know the result here, we got -2. So y must be -2 plus 2 is 0. So the original point must have been the pre-image was 12, 0. So if this would actually be point A. This would be what we refer to as A prime. That notation indicates that it underwent a transformation. That's the new one. That's the result. Primes. Maybe that's something you're familiar with. Maybe it's brand new. So point X, which is the pre-image, is at 5, 2, and it is translated a certain amount, and the resulting X prime image is 7, -4. So it went from the pre-image to the image. What is the coordinate notation or the rule for this translation? So I started with x, y, and what happened to my x's? How do you go from 5 to 7? You're going to add 2. From 2 to -4, I'm going to subtract 6. So x plus 2, y minus 6. So notice I'm not on a grid for all of these. So this meant it went right 2 and down 6. Let's do some more. If you feel like you want to pause the video and try some, go for it, especially if you've printed these out or right now you've got these, try it. So description, I mean verbal. Coordinate notation is what we were just talking about with where you do the XY arrow. So this is my original one. This is the pre-image. This is the image. Pre-image, image. I'm going to go that way. So be careful. You're starting with the pre-image. The description is I'm going to go left. You know what? Let's get real nitpicky here. Translate left. What is that? 1, 2, 3, 4, 5, 6, 7. 7 units. So coordinate notation, XY becomes, do not forget this, X minus 7, Y stays the same. What about this one? It's going to go from here to here. So I'm going to go down 1, 2, 3, 4, 5. Translate down 5 units. XY becomes X, Y minus 5. Ooh, this one's got both, right? So pre-image, image. I'm going to go left, 1, 2, 3, 4, 5. 1, 2, 3. So translate left 5 and up 3. So XY becomes X minus 5, Y plus 3. And this is true. This is like the rule. That is the equation. Think about it like that. Let's take a look at some shapes. I don't need to look at every point because it's rigid. I only need to focus in on one. So if I want to look at A, great. So this one, I'm going to say translate. What has happened? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Translate left 6, up 5. So XY becomes X minus 6, Y plus 5. If we had chosen to do that with C, that would have been fine as well. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, right? They all moved the same amount, and that is why this is rigid. It maintained its shape and size because you took it and everything shifted the same amount. What about here? So pre-image, image. Pre-image doesn't have the primes. It's the original one. Sometimes there's multiple transformations and you'll end up with even more primes. That'll happen eventually. So this is going to say translate 1, 2, 3, 4, 5, 6, 7. Right 7 units. And down 1, 2, 3, 4. So XY becomes X plus 7, Y minus 4. If I wanted to write these in the opposite order, that's fine. I can say down 4 and right 7. I just like to start with the left right because that's what I should be writing when I'm writing coordinate notation, right? I'm not going to stick the Y first. That'll never happen. So that's why I always like to be consistent. But if you want to look at your vertical change first, that's fine. Okay, so a few more. We're almost done. So the vertices of a triangle, so now this one's not graphed yet, are at -5, -3. I'm actually going to graph it as we do this. 1, 2, 3, 4, 5. 1, 2, 3. And label. So that's D. -3, 1. 1, 2, 3. 1, E. And F, -2, -1. So here's my original triangle. The translation of the triangle is described by this notation. Identify the coordinates, then graph and label the pre-image and image. So I already did this. I graphed and labeled the pre-image. So identify the coordinates. So this means that it goes right 7 and up 2. Right? So I'm going to go right 7. 1, 2, 3, 4, 5, 6, 7. You know what? Let's do this. D prime. If it goes right 7 and up 2, right 7 is going to be 2. Up 2, -1. So 2, -1. Is that D prime? 1, 2. 3, 4, 5, 6, 7. 1, 2. Yeah, that worked. So D prime, E prime, right 7 from -3 is 4. Up 2 from 1 is 3, so 4, 3. 3, E prime, and then finally F prime. And notice I'm labeling it with the primes. F prime, -2 plus 7 is 5. -1 plus 2 is 1. 1, 2, 3, 4, 5, 1. F prime. So when I connect these, if it doesn't look like it's the same triangle, just moved to a different part of the graph, I made a mistake. It is. My graphing's not great. Okay, so I'd super encourage you, if you haven't tried one on your own, is pause the video and try this one now, because we're coming to the end of this lesson. So the vertices of figure A prime, B prime, C prime, D prime are these. Oh, look at that. They're primes. This is the image. A transformation has already happened. So the translation of the figure, of the pre-image, is described by this notation. So it went right 5 and down 2. So I want to figure out what is A, what is B, what is C, and what is D. And then I'm going to graph it all. So I want to undo that. To get to A, I ended up at 1, 1. So I want to undo that. I want to go left 5 and up 2. I want to undo this because I'm going backwards, right? Like that's the whole idea of backwards. So instead I'm going to go left 5, -4, and I'm going to go up 2. Instead of going, so here, I'm going to start at 2, 2, and I'm going to go left 5, and I'm going to go up 2. I'm going to go 4, -1. I'm going to go left 5, that's going to be -1, and up 2, that's going to be 1. Left 5, up 1. No, up 2. My answer is 1. Right, so let's see what this looks like. I'm going to graph the primes first. You know what? I'll graph the one we just got. -4, 3. 1, 2, 3, 4. 1, 2, 3. Label as you go. There's A. -3. 1, 2, 3. This is a quadrilateral, right? 1, 2, 3, 4. B. -1, 1. -3, 1. Let's see. I'm curious if I graphed it right, but I don't know if any of you guys are yelling at me right now. It's okay. Okay, so A prime, 1, 1. There's A prime. Let's see if that makes sense. 1, 2. I went down 2. 1, 2, 3, 4, 5. Right 5. Oh, I did it. There's A prime. A prime, we're good. 2, 2. B prime. That kind of looks good, right? 1, 2, 3, 4, 5. 1, 2. Did it. D prime. No, I'll do C prime. 4, -1. 3, 4. These can get a lot when things overlap. 1, 2, 1, 2, 3, 4, 5. Was that C prime? That was C prime. Whew, close call. 1, 2, 1, 2, 3, 4, 5. Perfect, got it. And finally, D prime is 2, -1. 1, 2, 1, 2, 3, 4, 5. I think I got them all. Right, so everything moved the same amount, so it maintained its shape and size. I don't like how I labeled that. Fantastic, so that was working in reverse. These are our last two. Final two, guys. The vertices of this triangle, right? So I don't have a grid here. We're going to try to do these without a grid. A translation of the triangle results in this. Use words and coordinate notation to describe both. So I'll do the words and I'll do the coordinate notation. And you know what? I'm going to write this in before I even do anything, before I even like read the question, because I know coordinate notation is going to start with that XY. So since it's a rigid transformation, it does not matter which point I choose to pick. You know what? I think I'm going to look at M to M prime. How do you go from 4 to 5? You add 1. How do you go from 0 to -1? You subtract 1. Let's see if that works for a different point. What if I wanted to go from K to K prime To go from 1 to 2, I add 1. To go from 2 to 1, I subtract 1. It shouldn't matter which one I pick. If I look at L to L prime, 0 to 1, I add 1. 0 to negative 1, I subtract 1. It's rigid. They're all changing the same amount. So how could I put this in words? This translates, remember we're going to be precise, right 1 and down 1. Right 1 and down 1. Okay, this final one. This is it. The vertices of this quadrilateral RSTU are the translation. After the translation is performed, you get these. Use words and coordinate notation. So again, coordinate notation, I'm going to start with that X, Y becomes. And I'm going to start with coordinate notation. So let's look at R. R to R prime. How do you go from -3 to -5? Think about a number line. Going left on the number line. I don't even know if that's the right left. That kind of looks, I guess I'm flipped. I'm going left 2 on a number line. From -3 to -5, X minus 2. -3 minus 2 is going to be -5. What about 1 to 4? I'm going to add 3. Let's say we're not confident with that. Let's look at U. Okay. -1 to -3, I'm going to subtract 2. -1 to +2, I'm going to add 3. I shouldn't have to look at them all. They're all going to be the same. But if you're not confident yet, 2 to 0, subtract 2. 3 to 6, add 3. Right? And finally, T to T prime, 3 to 1, subtract 2. 0 to 3, add 3. Right? So this is a translation. So it translates left 2 and up 3. So hopefully you've got some confidence with translations at this point. There's so much more practice there. You can use the supplemental resources. And make sure that you have finished your notes. And if you need to go back and do that, you are going to be submitting them. So make sure that they get submitted so that we can kind of learn more about you as a learner and a student and offer support and suggestions that are appropriate for you, as well as the activity that goes along with this lesson. So in this lesson, like we did a lot. We did even more than this objective, right? So we introduced rigid transformations and we went ahead and we really like dove into what exactly a translation is. The one thing, and I said this, that we didn't really talk about was translating lines, as that will be something that we will be doing together next time in your next live session. So if you need to go back and rewatch anything, feel free to do so. Other than that, thank you guys for watching, and feel free to go back and rewatch and ask questions. Thanks, everyone.